Welcome to the webinar Parametric CAD Modeling from 3D Scan Data with FARO Laser ScanArm. We are using the software RapidForm XOR. I'm Tobias Klein and I will show you the presentation today. Our software is RapidForm. Unlock the power of 3D scanning, and I'm in charge of product management for the EMEA region. Let's start with some overview over our software family. The software family RapidForm XO consists of three packages, three main products, which is XOR Redesign, XOV Verifier, and XOS for scan and surfacing. As a matter of fact, XOS is a light version of XOR, which is suitable for organic shaped and mesh-based modeling, reverse modeling, freeform surface reverse modeling, and for cultural heritage, art, and organic shaped shapes. And XOR is suitable for CAD reverse engineering when you need to have specific dimensions and specific values to edit. Then you can use parametric hybrid reverse engineering way in RapidForm XOR to create parametric CAD models directly from 3D scan data. RapidForm XO Verifier is used for systematic quality inspection, comparison between scan and CAD data. You can also compare scan against scan data, and you can also dimension scan data only. And you have the whole functionality in XO Verifier from scanning until report generation. Some words about our company. Our company is Ines Technology, which is in Seoul in South Korea. And we have several offices over the world. Ines Technology was founded in 1998 with over 100 employees now, including more than 50 developers. So more than half of our employees are developing new features for our software. And we have sales and support in more than 37 countries, divided in three big regions. This is Asia Pacific, Asia Oceania, America, and Europe. And we have over 250 sales partners. Okay, about RapidForm XOR, we want to talk today. RapidForm XOR is our reverse engineering suite. Reverse engineering means not only get the shape of a part into a CAD file, but also get the design intent of a part into the CAD file. And this is how we do it. We go from a 3D scanner, actually from any digitizing device which you can find in the market. In this case, we want to talk about the FARO arm scanner. So we acquire the point cloud from the FARO arm scanner, even using a live scan interface from within RapidForm. Then we create that point cloud, we create a mesh, and we can create a CAD model using a parametric CAD kernel within RapidForm. And then we can live transfer this parametric CAD model to 3D CAD applications like SolidWorks, Pro Engineer, Unigraphics, or at least at the moment Siemens NX, and other things like AutoCAD Inventor. And one word about the evolution of computer-aided reverse engineering. Actually, in 1992, it started to develop the reverse engineering, the 3D reverse engineering with design surfacing. Some points were captured, and using those points, curves were created, and from that curves, loft surfaces were created, and those loft surfaces were transferred to CAD. Then around 2000, the polygon fit surfacing method was created. There's used a mesh and a mesh fit method to fit NURB surfaces on top of the mesh. This is used by RapidForm until 2006. Geomagic, SolidWorks, Paraform, they are still using this method. The big drawback of this method is that you need to stick to the scan data as close as possible. You have no freedom to detach from the scan data which you're surfacing. On the other side, the CAD applications, they developed the reverse engineering method as well. And they have a CAD functionality, so they can create 2D sketches, and they can create CAD operations like extrusions and something. So they use the very limited point handling algorithm and made cross sections through those points or mesh, and created curves and created solids or surfaces based on those curves. But also this was a very tedious method to create CAD models. Then in 2006, RapidForm invented the 3D scan-based hybrid CAD modeling. So in this case, we can use the design surfacing method from 1992, the polygon fit surfacing method from 2000, and we can use CAD methods from the Parasolid kernel, which we implemented in our software. So we have one software package which unites all three reverse engineering methods. Let's have a look at the analogy. You have to get a 20-page document from coworker to edit and submit to your boss. In which format would you like to receive the document? Basically, a fax copy is a representation of the document, but you cannot edit it. It's just a plain document, and if you want to change something, then you have to rewrite the document. So the analogy is the point cloud. The point cloud is just a dump shape information in 3D space. You cannot very easily change it. Numerically, you cannot change it. And if you need to redesign it, then you have to recreate a model from scratch. The PDF file is one step forward. So in the PDF file, you can at least copy and paste something out of the document and use it again in another document. A similar thing is the IGES file. So the IGES file is already capable of being read by a CAD application. So you already can get some edges or some curves out of the IGES file, but you still need to create your model. And the last file format is the Word file, which is fully editable in case of the document. And in case of the parametric CAD model, you have the fully functional model. You have numeric values, which you can change, and you can change the whole model shape based on those values. And let's say you start with that fax. In our case, it would be the point cloud or the STL file. So how would you prefer to make the new Word file, in our case, the parametric CAD model? One way is to retype the document. So in our case, do cross sections and use CAD operations to create your CAD model again. Then your output is functional, but it needs a lot of work. In case of the fax document, you could use OCR software or an optical character recognition software, which recognizes the character and outputs a text file, which you can use and edit your Word. In XOR, we have similar functionality, which extracts the feature information from scan data. And with this feature information, you have the numeric values and you have parametric objects, which you can edit in XOR and which you can export to CAD. XOR is much faster than just cross-section plus CAD modeling. We can use different algorithms like a mesh sketch. We have a redesign assistant which helps you with redesigning or reverse modeling your scan data to CAD data. We have the accuracy analyzer, which lets you know at any time of the modeling process how accurate you are doing your reverse modeling job and how high quality your surfaces are. Then we also have auto feature modeling, which lets you extract features from the scan data in just a blink of an eye. Now let's talk about the speed advantages. Actually, how much faster is RapidForm? 20% or 30%? In fact, it's over 700%, 700% in average, many cases more than 2000% speed advantage. I'm not talking about the scan data cleanup time, which shows even more disparity. As a matter of fact, in RapidForm, you don't need to scan the whole part. You can scan only the part which defines features in the model. And then based on those feature information in the scan data, you can recreate your CAD model. The more complex the shape, the more time saving you have. Let's have a look at that chart. We compared with a neutral service company, we compared the reverse modeling from that scan data compressor wheel to the reverse modeled CAD. And that was done in Siemens NX, in Pro Engineer, in SolidWorks, and in XOR. And we can see in XOR, we need at least half an hour. In Siemens NX or in SolidWorks, which uses the same kernel, the Parasolid kernel, we need probably 2 or 3 hours. And in Pro-E, we need even more time. This is because different kernels interpret different functions a little bit different, and you have to spend more time to get a solid model complete. In XOR, you have many functions which support you in redesigning, and there is a small additional bar in the XOR bar, the red one. This is the time you need to transfer your model from XOR into the CAD application. So you can work in XOR, you can completely create your CAD model in XOR, then you transfer your CAD model from XOR to your native CAD application. How is this possible? Actually, we have several design assistants that get you the information you need from your scan data whenever you need it. So whenever you have a fillet information in your scan data, you have a fillet, whether it is a constant fillet or a variable fillet or even an elliptical or conical fillet, you can just extract that fillet information from your scan data, because we have a feature recognition which segments the scan data based on curvature. Then we also have the smart dimensioning by automatic value extraction. So whenever there is a value in the feature, then you can also extract that value, and it supports you in creating your CAD model. As well, we have an accuracy analyzer. The accuracy analyzer is showing a color map. This color map is showing the deviation between the CAD data which you are doing and the scan data, which is your dimensional source. Then we have feature wizards like Loft Wizard, Sweep Wizard, Revolution, Extrusion, Pipe, and Primitive Wizard, which instantly creates sweeps, lofts, revolutions, extrusions, pipes, and primitives from scan data just by clicking them and extracting the design intent. If you are already familiar with CAD, with 3D CAD, then you can immediately start using RapidForm XOR. We have not a bridge, not a tool which is necessary to create a CAD model. We can directly create inside a CAD kernel. So we are a CAD reverse engineering software. CAD users already know how to use it. The output is a complete CAD model, same as you do a blank page design, but you always have the reference of the scan data. We can do a feature output for the SolidWorks, for Siemens NX, PDC, Pro Engineer, Wildfire, and we are currently working on a transfer to Inventor. Also, we support a direct geometry for AutoCAD and CATIA V4 and V5 as save as native file format. And if you don't have one of those CAD applications, then you can use IGES, STEP, and Parasolid file format, and you can fully edit every feature which you created inside XOR. You can fully edit inside XOR. So what is it if you have not a parametric CAD model? If you have an organic shaped CAD model, you can also use XOR, or you can use XOS in this case. You can use auto surfacing. This is shown on the left side, or manual surfacing, where you create the curve network for the boundary fitting method manually. This is shown on the right side, and you can still get IGES, step, and parasolid surface or solid models out of the scan data very quickly. In case some models are partially prismatic shaped and partially organic shaped, or the shape is generated by FEM or CAE methods, then you can also combine auto surfacing or manual surfacing with solid modeling methods. We are a hybrid modeler, and we can go back and forth between surface modeling and solid modeling and combine both modeling methods in a hybrid way. Some samples and summary I will show. A case study of 2011 from the business development team. We had worked together with a mold maker for a car seat mold. These actually are the parts from the mold, and those parts were fully reverse engineered in SolidWorks from scan data. Then from the Korean government, there was a ELearning program. On the left side, you can see some contents which were available before we used our software to create a 3D e-learning module for that engine assembly, which you can see on the right side. Those are the parts which were created completely in Revit from XOR. The complete engine was disassembled and scanned, and it was reverse engineered in XOR. Here you can see some assembly screenshots and some screenshots of the kinematic animation and of the FEM animation. We can also do a negative solid modeling. That means if you only have a mold, but you don't have the real product, then we can scan the mold. And from the mold, we can create a solid model of the real product. So we can use a Boolean operation to create a negative solid from the actual part. Okay, I will show a live demonstration with Revit from XOR. In this live demonstration, I'm using a part which is already used in some FARO webinars. This part is just a sheet metal scan data part, and you can see this is a scan data part. I'm zooming in, then you can see the triangulated mesh. So this is just a scan data part, and this scan data does not know anything about features, about geometry. It is just basically point information in space and the triangle normals, that's it. Now we are using an intelligent algorithm to extract feature information from that scan data. So for example, here in the middle we can see there is a revolution, or in this case we can see there is a plane in scan data. So you can also find out many features like revolutions, planes, or even other freeform shapes. And based on that features, you can do a coordinate alignment, for example. After done the coordinate alignment, you can start sketching. So you can, for example, get a plane, like a CAD plane, and from that CAD plane, you can create a base solid with the outline of this model. I will do that using a mesh sketch. Normally in CAD, you know about sketching. Now we are using the sketch in combination with the silhouette from the scan data as a reference for our 2D sketch. And I'm moving my section plane through my scan data set to get the outline. And now I'm creating a volume. And this volume is basically a volume where I can project a silhouette of my scan data down to my sketching plane. Now I can see this pink line. This is the silhouette of my scan data. And this silhouette of my scan data can be redrawn with CAD elements. So I just double click the features. This is my line. Now I have the lines. Then I can create fillets. And I can trim elements with each other to get a close profile. To check whether I have a close profile, I can use the accuracy analyzer, and I can also check whether my reverse engineered 2D sketch is reflecting the actual shape of my scan data. I can set a tolerance, in this case plus minus 0.1 millimeter, and everything which is green is inside those tolerances. If something is not inside the tolerance, then I can just move this a little bit to let it be inside the tolerance. When I'm satisfied, I can close the sketch, show the scan data again, and now I can make a basic CAD operation like an extrusion. And now I am using the redesign assistance to help me find the extrusion depth. In this case, I do not want to extrude it blind. I want to extrude it up to a certain region. In this case, I have a region down here. And I want to know how far I need to extrude. I need to extrude up to a maximum distance position. So this is my actual distance. I want to extrude this part. Now let's check the deviation to the original scan data. And as you can see here, we basically got the outline of the scan data as a base solid. Now let's create this revolution part in here. We have a revolution wizard. This revolution wizard accepts features which are named as revolution. We can also define a custom revolution axis. In this case, it would be the same axis. I need only a partial shape because this is not a full revolution. And I want to use lines and arcs when possible. I want to create a solid, therefore I cap ends. And I want to see where is the best, longest profile I can use for guessing that revolution from scan data. Now I get a revolution. Now I need to define how far I want to turn it. Now this is the revolution body. However, the revolution body sticks out of my solid body. So now I need to change my revolution body. As well, my revolution body is not complete here. As well, I need to change my revolution body. So now I'm making use of this parametric history tree, which we have here. We have a sketch for that revolution, and I can go into that sketch and edit it. I can limit my revolution extend and trim my sketch. Like this. Make sure it is still inside my part. Okay, maybe let's make it a little bit shorter. Okay, now it's completely inside my part, and now I did this revolution just by a few clicks. Let's have a look at the deviation. So this is that shape. Now I've prepared some sketches. I can do the same way which I did before. Up to a region, trim with mean distance position, and I can select my region in the scan data directly. Then I can cut out this part from the scan data. That way I can complete my model in a few steps. Extrude a sketch which I created before and cut out this sketch from my scan data. With these sketches I get my bottom trim line of my sheet metal part. After that we will apply a hollow process. So the bottom shape does not interest right now. So, and let's make another. Okay, now we need to get some fillets. Let's make a small constant fillet here. We have a magic wand. This magic wand can estimate the fillet radius from scan data. In this case, we have a 3 mm fillet. So this is also the redesign assistant. It helps us guessing the value from our scan data. In this case, we have a 9 mm fillet, or we can even edit that fillet with the deviation color mapping. So let's say we have a 15 mm fillet or 12.5 mm fillet. You can check the deviation during your filleting process. After the filleting process, we can make a sheet metal model using the hollow feature. We need to select the body and we need to select the wall thickness. Then we can remove some faces which should be not inside the sheet metal part. And then we will get the sheet metal part. So, but now I forgot to make one more fillet. But this is not a problem. We can just roll back in our history tree, roll back before making the hollow feature, and I can create one more fillet here. Then I will roll forward to the end, and the model will reflect my change, so my fillet is also creating the wall thickness here. So this is basically the sheet metal part. Now I can keep doing extrusions and punch those holes through. So that's it basically. One more to go. It is actually a forward construction approach, but you are always relying on the scan data, and you can always guess features from the scan data. Here I need to select cut, not merge, because I want to make holes, not pins. So you don't even need to follow the scan data. You have the freedom, you can decide what you want to do. You can create a completely new model based on the scan data, an idealized model, a CAD model, which has dependencies like parallelity, concentricity, something like this. Or you can follow the scan data and create a very nice surface fitted model. Both is possible. Okay, in this case, I want to show you one more thing. We have an interface with the FARO arm. So you can directly operate with the FARO arm and with the part, and you can not only scan data, you can also probe data and create sketches directly with the FARO arm. So in this case, we are doing rectangles, circles, cones, spheres, cylinders. So as well, 3D and 2D features are possible. And we can seamlessly switch to scanning and combine every feature which we created. So using the 2D sketching and probe some circles, for example, and then later on set the concentricity between the circles and get some dimension from the circles. Or create your base solid from the scan data and then use the sketches from the circles and use the bodies which you probed before and combine them with the Boolean operation. Here we create that base solid based on the sketch, just using sketching from scan data and extrusion. And we are using those sketches and also the previously tactile probed features and combine them. This is live scan. And when we finished our CAD model, then we can go directly, now in this case, the model which I did before, we can directly transfer this model to a CAD application. So in this case, we transfer this model to SolidWorks. This is still inside Rabbit form. We have a look at our compatibility, which tells us during modeling which function is compatible with SolidWorks, and then we can start the live transfer to SolidWorks. And in SolidWorks, the parameters are exactly the same as in Revit form. So in SolidWorks, you can directly go into a parameter and edit a length or a radius or a pattern number, something like this. So this was the presentation, just quickly about Rapid Form XOR. And I thank you for your interest in that demonstration. And now we have some time to answer the questions. There is a question about what is the difference of XOR, XOS, and XOV. Okay, XOR is basically a full reverse engineering suite. You can use everything from getting scan data, manipulating scan data, so scan cleanup from the point clouds, going to mesh, cleaning the mesh, modifying the mesh, creating manual curve networks, creating NURBS surfaces, creating CAD features, extracting CAD features from scan, and building the whole model in a hybrid way. Surface modeling and solid modeling and parametric history, and transfer the whole package to a CAD application. This is XOR. XOS is a small version of XOR basically, so it is only for organic shaped or archaeological objects or organic objects or artificial objects, something like this, which is very freeform and which does not need to be a CAD model with rectangularity and something like this. So XOS has all the features from scanning, mesh creation, mesh modification, and basic surfacing. And XOV is XOVerifier. XOV is the quality inspection suite, so you can do everything from scanning, a little bit of point handling and mesh handling, a little bit of surface handling as well because of some CAD data, healing, fixing, and then comparison between point or mesh scan data and CAD data, which is surface or as well mesh. So you can compare CAD surface against scan, or you can compare scan against scan as well. And finally, reporting. And in XOV, all this can be done parametrically as well. So you can repeat the whole process just by clicking one button with a second set of scan data. Okay, there is one more question. I have noises after I triangulate my scan data. How do I fix this problem? Because it's difficult for me to do some remodeling. I prepare something to demonstrate this. Actually, we have a quick start guide in Rapid Form. This quick start guide is a very good self-learning tool. And in this quick start guide, we have samples for many applications which you can come across. So in this case, we have also a case for mesh handling. And you can simply import that file. Then you can see this could be sample data with a line type laser scanner. This scan data actually has much of noise. And now you can just clean up that noise by double-clicking the scan data. And we have several functions to do this. For example, we have a healing wizard, or we have here an enhanced shape function. This enhanced shape function is basically a function which smoothens regions which has not much curvature, and which sharpens a region which has high curvature. So just to show you that result, we can just simply calculate it. And this is the final result. So we have a very smooth shape when in areas where we don't have a big curvature, and we have a very sharp shape in areas where we have a big curvature. And we can also evaluate how much changed the scan data. So within our accuracy analyzer, we can define a tolerance with plus minus 0.1 millimeter in this case, and we can check how much the actual function changed the scan data at this time. There is another question. CAD correction. Can XOR do handling with CAD for partial modification? Tell me about CAD correction. Yes, we can do CAD correction. CAD correction is basically refitting CAD surfaces on top of scanning. So in that case, let me show you something. So when you check the deviation, you have CAD data and scan data, and check the deviation, and the deviation is not satisfying enough. Then you can use the CAD correction feature, refit. You can choose a scan data, and you can choose some faces. Like this. And then you can apply a preview, and then the faces will be attached to the scan data. So it is more or less combining CAD operations with mesh fit operations. And this is the result. So the deviation is minimized, and your CAD model is more reflecting the actual shape of the scan data. Okay, so there are some more questions. I will get a log of those questions, and there are actually many more questions, and I will get a log of those questions, and I will try to answer those questions each by email. And I want to thank you for attending this webinar.